Okay, so the next example says find the intervals where the function g of x is equal to x to the fourth minus 4x cubed is concave up and concave down. So anytime we're trying to talk about concavity, we definitely need to take that second derivative. So let's just go ahead and get this started by taking our first derivative, because, well, that would be helpful. So I'd have g primed of x is equal to 4x cubed minus 12x squared. And then taking the second derivative, I would get g double primed is equal to 12x squared minus 24x. All right, and then just to kind of figure out where our not necessarily critical values are, but the numbers that we're going to put on our sign chart, because yes, sign charts don't get us any points, but they're still super useful, so I would still recommend using them to help explain things in your brain too. So I need to probably set this equal to 0, so I've got 12x squared minus 24x is equal to 0. I can factor that pretty quickly, so factoring that should give us a 12x on the outside with an x minus 2 on the inside, still equals 0, so x could equal 0 and x could equal 2. Alright, so then all we gotta do is make our happy little sign chart. So we've got our values at 0 and 2. Alright, and from here we can plug in numbers and we can figure out, okay, if I plug in -1, I should get a negative times a negative, which overall is positive. If I plug in 1, for example, I should get a positive times a negative, which will give me a negative. And then if I plug in 3, for example, I'm going to get a positive times positive, which overall is positive. Okay. And that makes sense because, well, that's a parabola if we look at that. So, should just be something like that if I'm looking at the graph of the double derivative. Not so bad. And then we know calculus absolutely loves our explanations. So again, write it out, write it out, write it out. Please don't use the word it. I don't know if you're talking about g primed, g double primed. Be specific about which one you're talking about. Most of the time we will be referencing the original function, either because of our first derivative or our second derivative. So for example, we would say g is concave down on 0 to 2 because g double primed is less than 0, and then g is concave up on negative infinity to 0 union with 2 to infinity. Alright, because g double primed is greater than 0. Alright, so again, in this particular case, I'm referencing the original function, and my justification is using that second derivative both times. Please do not use the word it. A lot of the times you will be talking about your original function with reference to either your first derivative or your second derivative, but make sure you are specific